Bismillahirrahmanirrahim. As students, now we are going to start our new topic, and that is the introduction to finite differences. Students, let me tell you that this is a very easy topic and very easy concept. And the main idea behind is that here we are dealing with the values which are discrete, which are not continuous. बेटा हम लोगों ने देखा कि अगर हमारे पास कंटिन्यूस डाटा पॉइंट्स हैं तो हम नॉर्मल जैसे डेरिवेटिव है आप डेरिवेटिव का कंसेप्ट यूज़ करते हैं नॉर्मल आपके प्रोसीजर्स हैं फर्दी अभी आपने पढ़ा होगा कंटिन्यूस डाटा के लिए लेकिन यहाँ पे अब हम क्या कर रहे हैं कि हमें हमारे पास डिस्क्रीट पॉइंट्स हैं मींस देयर इज अ गैप बिटवीन द पॉइंट्स सो वी आर गोइंग टू फाइंड आउट द इवन डेरिवेटिव एंड इंटीग्रेशन फॉर दोज पॉइंट्स. And sometimes it happens that we are just given the information uh, within the particular points, not at all the points. For example, if we are concerned with the information regarding the uh, coronavirus patients, for example today and the tomorrow's or the day before yesterday or maybe the previous month, and so not every time every moment we are not going to calculate the amount number of patients, but we are just concerned with the number of patients on daily basis, for example today and then at the same time tomorrow, maybe the day after tomorrow, or the maybe yesterday or the day after before yesterday. So in this way we are concerned with the information where the values are discrete, they are not the continuous. So these data points at which we are interested to see the function value, so uh, they can be of equal variation, they can be of unequal variation. So it depends on the data what type of variation this is. So students, let's see what is the finite differences. So first of all, just see the very simple concept here, and then we will talk about the other things. So students, for a function y is equal to f of x, finite differences refer to changes in the values of y dependent variable for any finite equal or unequal variation in x that are independent variables. So see student, here we have particular numbers, so x naught, and here x1, x2, x3, x4, x5, x here x6, and here so we have the values of the function at these points. So sometime it happens that the only the table is given where only the five values are given, where the information regarding those points are available only, not at all the points. So there are many things in which we cannot have the data on the continuous basis, so we can have the data on the discrete basis. So students, just like the normal derivative, like we have the derivative operator, so but that is for the continuous data points. So similarly we have the other operators as well for the discrete points, but the idea behind is rather similar and the same but very simple as well. So this is the first operator. So students, uh, we had seen that in the previous slide that we have some point, for example x1 and then x2, and in between these 2 points, let's say the distance is h. Maybe this h is not equal for all the data points, but for the time being we are now considering the data points to be same. But of course, we will discuss the cases when the data points are at different locations at different sizes where h is different. But anyways, let's first talk about the increment operator, that is e, or sometimes we call this one, mainly this one is called as the shift operator. So students, what is the shift? Shift, uh, like in common words, in normal way, we simply mean shift means to change to the next level or change to the previous level. So shift operator E means, students, for example, here we have a function f of x. Just keep it in mind that the operators which we are going to study here, like the uh, shift operator or the differentiating operators, like forward operator, backward operator, uh, central operator. So all these operators are on the functional values, not on the uh, domain value, but on the range values. So students, E of f of x. So what does it mean? So this E, what it changes basically, this E changes or shifts f of x to the next level. So E of f of x means E of f of x plus h, means basically the change is in the function, but why this change is appearing? This change is because to the change in the domain value, and that is your x. So x plus h is your next point. So the function value at the next point is your now the answer of the shift operator. तो बेटा हम क्या करते हैं कि हमारे पास अगर आपके पास e of f of x है, तो हमने सबसे पहली बात ये कि जहां पे भी ऑपरेटर है हमारे जो फाइनल आंसर देंगे वो फंक्शन के अंदर आंसर देंगे, ना कि आपकी डोमेन वैल्यूज में आंसर देंगे। इंडिपेंडेंट वैल्यूज में आंसर नहीं देंगे बल्कि डिपेंडेंट वेरिएबल में। तो इसका मतलब ये हुआ कि अगर हम एफ ऑफ एक्स में चेंज देखना चाह रहे हैं, शिफ्ट देखना चाह रहे हैं आगे की तरफ या पीछे की तरफ हम बाद में बात करेंगे। अगर आगे की तरफ हम शिफ्ट देखते हैं तो ई ऑफ एफ ऑफ एक्स इज इक्वल टू एफ ऑफ एक्स प्लस एच, or in simple words we can also write this one as e y x. Yx means, student, this does not mean that we are going to find the derivative here. E y x means the function of value of y at x. So this is basically equal to y at x plus h. So this is called the shift operator. If you operate this time two times, like e of f of x, like at one time we have already applied and then we are applying on the second time, so then even then it will be, so second change step, second shift, so f of x plus 2h. But students, if you want to go back like the previous value of the function, then what you are going to do is, so e minus 1 is f of x is equal to f of x minus h, where e minus 1 is the inverse shift operator. Now students, the next topic is differentiating operator. So these are the operators and where the forward operator and backward operator will be mainly used, where we want to see the changes in the function, like how we change. And basically this concept is very similar to the concept of derivative, but for the case of discrete values. So students, what it says that if y naught, y1, y2 and so on up to yn be the values of y for corresponding values of x naught, x1, x2 and so on up to xn, then the differences of y are defined by y1 minus y naught, y2 minus y1 and so on, yn minus 1, and they are denoted by different operators. So we will talk about the different operators in this section. So so this is the main topic for you, because the methods which we will talk about in your course, so which are recommended topics, so we will definitely use these concepts for those topics. So let's move to the next slide, student. So the first one is forward difference operator. So students, what is the forward difference operator? It is an operator like just like the derivative. It is an operator just like the shift operator. So this is denoted by del. So students, this is the del sign here. So how you operate this one? So student, this is important that this is the forward difference operator. Forward, like from the word, it is quite clear that you are considering the next entry basically, right? So students, if you are applying the forward difference operator on any function y at the value at value x, then what will be its answer? Its answer would be y of x plus 1 minus yx. So first of all, before looking at this, I think this is quite simple to see this notation. So del f of x means the forward operator of f of x is equal to, see, since this is the word is forward, so first of all consider the next value. So f of x plus h. And then since we are seeing the difference operator, so this is the difference, so difference is the previous value, difference from the previous value. So f of x plus h minus f of x. And what is h here? H is the height of the differencing, or just the difference between the uh, uh, value of the x. So x, then x, let's say x naught is the first value, then the next value is x1. So x1 is equal to x naught plus h. So students, so this is your first forward difference operator. And now if you want to apply the forward difference operator on y naught, the first function value where x naught is given, so student, the answer would be y1 minus y naught. Similarly, del y1 is equal to y2 minus y1, and so on. Del yn is equal to yn plus 1 minus yn. And now students, if you apply the second means the second derivative, or means the second forward difference operator, so then what you write it, del square y naught is equal to, students, so actually del square is equal to del into del. So del into del means you are applying del on the first operator, first forward difference operator. So it means uh, del of y1 minus del of y naught, because del y naught was y, del y naught was y1 minus y naught. But if you see students here, this one, so this one you have, so del is simple, one del is y1 minus y naught. And the second operator is basically your second derivative means, and that is del of del. So students, in this case you have, now you are applying once again the second, again the del on y1 minus y naught. So that is equal to y2. So what is del y1? Del y1 is equal to y2 minus y1. And what is del y naught? Del y naught is y1 minus y naught. So the answer is y2 minus 2 y1 plus y naught. And students, if del ny naught is to be calculated, so this is the formula, but you don't need to remember this formula, because for you, like, the important thing is that you just calculate up to maximum, up to the third value, the third derivative. And even you don't need to remember the formulas, because even if you just uh, remember the table how you calculate, so in the next slide I will tell you how to find out the table for the derivative for this difference operator, then the things would be very easy inshallah for you. So students, this is the forward difference table here. And now if you understand the table, so even then you will not need of remembering the formulas. So this is very simple table, students. So what it says, so students, if you have the x values here and the y values are given, see, x values x naught, x1, x2, x3, x4, and x5. And similarly, so students, you can have so many values here. And the function values are y naught, y1, y2, y3, y4, y5. So now students, if you are applying the first uh, power difference operator, so what will be in its answer? You know, the formula is that you are taking the difference of y1 minus y naught. So this difference is called as del y naught. Students, this is very important that you write y naught here because this is the first forward difference. So you write in this middle value, middle point. Similarly, y2 minus y1 is del y1, and here del y2, similarly del y3, del y4. And now students, if you apply the second derivative, second forward difference operator, then this is the difference of this one. So del square y naught, del square y1, del square y2, del square y3. And similarly, the third difference operator, power difference operator, so del 3, and y naught, del 3 y1, del 3 y2. And similarly, students, here you can find out the different forward operators, second order, third order, fourth order, fifth order, whatever you like. So student, what is the advantage of this one? See, you don't need to remember the formula now. You have, if you have these values, x values, and you have the y values, so you can just find out the difference, y1 minus y naught, just write it here, y2 minus y1, just write the difference here, y3 minus y2, just write the difference here, y2 minus y3, write the difference here. Similarly, if you just see the whatever the answer is, and whatever the answer is here, just see the difference here, so it will give you this one. Similarly, whatever the difference, whatever the values are, so just see the difference and it will be this one. So students, at one point, see, at one point, if you want to find out the values of the derivative at a point, for example, at the first point, like you say, the find out the derivative at this point. So if you are finding out the difference operators at x naught, so this is the first forward operator y naught, see, and this is second forward operator y naught, again the third forward operator y naught, fourth, fifth. So you see, this point is same. So the order, so the values are considered in this way. So this arrow basically indicates the direction of the differences from top to bottom. So in this way, students, you calculate the forward difference operator. And for example, whatever the value it was, so you don't need to remember the formula. If you have just made this table with the values, so you can say, okay, my answer is del 5 of y naught is equal to this one. And student, it is interesting to see that if you want to find out the first forward difference operator on x5, then you need x6 as well, but x6 is not available, so it means on the last point you cannot find out the first difference operator. See, you cannot, you can only apply it on the last value, x y4, y3, y2, y1. Similarly, the second one you can apply on third, the third one too. So in this way you simply move the things. So that's why you just consider the this arrow direction. So students, here we have different properties, and for the del c, like normal derivative, derivative of c is equal to 0, so the derivative del operator on constant is equal to 0, del operator, and then c is constant but function is there, so c can be taken out, so c can be out. And similarly, del a f of x plus minus bg of x. So students, uh, a can be taken out and then apply the del operator on f of x. Similarly, b can be taken out and take del to be outside. Oh, sorry, del, then apply the del operator on g of x. Students, now this is the uh, next operator, backward difference operator. This is very similar to the forward difference operator, and then we will see the example, inshallah. uh, because this is rather close to the first forward difference operator, so that's why I thought maybe it's better that we continue in this way. So students, what is the backward difference operator? So this operator is uh, this the notation is known as to be nabla. So this is the nabla notation. So student, also this is called the backward difference operator. So backward difference operator, also students, this is again the difference operator. So it gives you the difference like y1 minus y naught, y2 minus y1, yn minus yn minus 1. But this is very important, students. This is the backward difference operator. So it means you are going backward. See, if you are applying on del yn, oh sorry, nabla yn, backward difference operator on yn, then you start from yn, but then you go back and minus yn minus 1. In the forward difference operator, you had, like, if you have had considered yn, so you had started with yn plus 1 minus yn, not like this. So this is the difference basically. So the differences, so these are called the backward differences. Students, similarly, second difference, a backward difference operator on yn is equal to backward difference operator yn minus yn minus 1. And similarly, you can apply the third on the third order operator, and just like the forward difference operator, you can apply the backward difference operator, but the notation is somehow the different. And the important thing is that you are going from down to bottom to the top. In the case of forward difference operator, you are considering the um, operator from forward, from the top to bottom, but in this case you will consider from the bottom to the top. So let's move to the next slide to see the table. So see the students here. Uh, See x naught, x1, x2, x3, x4, x5, and then y naught, y1, y2. Now, what is the notation for this? Backward operator on y1, not on y naught. If this is y naught, then it means this was the forward difference operator, but this is y1. Similarly, this is y2, this is y3, y4, and this is y5. And similarly, if you see the difference here, this is called the second backward difference operator. Similarly, the third backward difference, fourth backward difference, fifth backward difference. And now see students, if you are considering the backward difference operator on y5, see again this one is first operator on y5, second operator on y5, third operator y5. So you are going from the bottom to top. So this arrow indicates the direction of the differences from the bottom to top. So students, in this way you easily calculate the values here. So let's move to the next slide. And now students, this is the central difference operator. Okay, I think this is not, you can simply read that one, but this is not much important here. But if you want, you can simply read the slide notes, because the methods which we are going to discuss in your course outline, so the central difference operator is not needed. But somehow if you want, you can that's why I have written them here in the notes. So if you want, you can simply read them. And this is the table for the central difference. So now students, this is the example, and what it says that form the forward difference table for the function f of x is equal to x cube minus 2x square minus 3x minus 1 for x is equal to 0, 1, 2, 3, 4. So it means student, how many values are there? 1, 2, 3, 4, 5. So total values are 5 basically. at which you need to find out the function value, and then we will make the table. And then it says hence or otherwise find del cube f of x. Also show that del 4 f of x is equal to 0. So this is important concept. We will talk about it later, inshallah, after this. So first of all, find out the values, student. F of 0. What is f of 0? Just put the value here in the function. It is -1. F of 1, just put the value -5. F of 2, -7. F of 3, -1. F of 4, 19. So student, just write the values here. You just write the values here, and function values are here. And now it says the create the forward difference table. So this is del sign. So del square, del cube, del 4. See, now -5 -1. So this is -4. -7 -5. This entry minus this entry, -2. This entry minus this entry, 6. 19 minus -1, 20. So similarly, students, now the next difference, -2. So this becomes as plus 4, 2. 6 minus into -2, so 8. 20 minus 6, 14. 14 minus 8, 6. 8 minus 2, 6. And now what it says find del 3 of f of x. So student, what is the answer here? So the answer is 6. And then it says and show that del 4 f of x is equal to 0. See, this is 0. So we have already done this example, but this is a very important concept here, students. You see, this is the third degree polynomial equation. See, x power 3, x power 2, x power 1 is constant. So this is the third degree polynomial. And if you find out the normal derivative, so then the third derivative will be a constant and the fourth derivative will be 0. So same is the case here, students. See, you can see the third derivative is a constant and the fourth derivative is 0. So we will use this concept in the upcoming slides. And here we will use the same concept basically. And students, this is important thing to be discussed here. Sometimes it happens that in the table, sometimes one value is missing, two values are missing, so we need to find out that value. So student, the main idea of finding basically those points or those values are using the concept of curve fitting. Like for example, if we have 2 or 3 points, so let me for example show you. uh, let's say we have, students, say 1 point here, 1 point here, and 1 point here. See here these points. So students, if you simply want to here, you see this middle point, one middle point is missing here. So if you want to join these points, so what you assume is that you simply feel that maybe if I join these points, maybe this is not a good curve, but so you will consider this middle point as well. So just assume using the curve fitting, you have made a curve on this, so you will feel that maybe there is a point here at this point, at this location. So that's why you just assume that maybe this is not correct, but in most of the cases the normally this is true, and this is a good approximation. And now students, uh, in the table maybe one value is missing, two values is missing, three values are missing, so we use the similar concept. And here, students, what you will use the same concept as we have already done in the previous slide, that if for example if you want to make a straight line, then you need 2 points, of course, to make the straight line. If you want to make a curve like of degree 2, second order equation like a parabola, so you need 3 points. If you want to have the equation of nth degree polynomial, so you need to have the n plus 1 So one value is extra values needed. But like in the previous slide, the degree was a third degree, and you need to have at least 4 points to make this curve. So students, this is important that fourth degree, fourth derivative would be definitely 0. So that's why we see here it says that to find the missing value of the data using finite differences, we presume the degree of the polynomial by the number of known observations and use the result del n plus 1 f of x is equal to 0, means the next derivative will be 0 for a polynomial of degree n. So let's move to the next slide to see an example, and then hopefully you will better understand this. So students, here it says that this is the example. Use the concept of missing data to find y5 if y naught is equal to -8, y1 is equal to -6, y2 is equal to 22, y3 is equal to 148, and y4 is equal to 492. And student, the question is find out the value of y5. So you need to find out the next value basically, and you are not sure what will be the value, but hopefully inshallah, going on the similar way, you will find out the next value, and that would be rather approximate. But of course this is an approximate value, so this cannot be the exact value. So student, first of all, you need to find out the fifth value. So just write the values x naught, x1, x2, x3, x4, and finally x5. And these y values are given here, students. See, y values are given, and since you don't know about this value y5, so you just write y5 here. And now students, just take the forward difference operator. So -6 minus into -8, so 2. So this is 28, 126, 344, and you don't know about the value of y5, so y5 minus 492. Similarly, the second one, that operator is 26, 98, 218, and then y5. So student, y5 minus 492 minus 344. So the answer is y5 minus 836. Similarly, so you arrive at y5 minus 1222. Students, see how many points are given. 1,